Hello everybody. My name is Francescogiuseppe Morabito, and well, I'm going to speak to you about the truss extrusion of WrapToR reinforced trusses. Now, before starting though, I would like to briefly give you an overview of what has sparked my imagination. And well, just before starting my PhD here, there were this company, Thales Unlimited, who revealed this machinery that could 3D print directly in space large truss of trusses. So, well, actually, we do study composite lattices here in Bristol. So I joined Ben and his group of WrapToRs, and well, I sat on the mission of developing a 3D printing system for our WrapToRs. Now, before starting the real presentation, just another little introduction from a historical point of view, because WrapToR is a patented technology. It stands for WrapToR Reinforced and was initially developed in Maryland in 2010 for the blade spars of Gamera first. Now, after having achieved incredible lightweight properties, they were extensively used for Gamera second, with a further reduction of 40% from an already weightless structures. But how were they originally made? Well, as said, is a modified filament winding system where the fiber-reinforced plastic longitudinal members are held on a rotating mandrel, and while they are being wrapped with the lattice, with the shear member lattice. Now, this is a little video that shows this, but as you can imagine, I wanted to achieve continuous extrusion. And to do this, I had to overcome the limitation of a reciprocation motion, and therefore I developed this coaxial winder where two rotating mandrel can directly wind on a well, in this case was on a moving while moving on a mandrel, they could directly wind all the six shear webs at once. Now, to then convert it actually 3D print with epoxy impregnated toes, I had to reshape the machinery in this vertical configuration, and the rail mandrel that was at the center was replaced with a mandrel that now allows that lets the core member slide while they are held in place. Now, of course, working with epoxy is very messy, and it's more messy when I am around. So this first machinery actually, but this first machinery has a separated impregnation twisting system, which you can see. I can't use the. Doesn't matter, no here. But the one signed by number 2, which is a station for winding and impregnating the fibers. Now, I would like to brag a little bit on how remarkable the properties of our trusses are and how good our finite element analyses are. But I will skip this, and I will invite you to come and visit me to my poster. Of course, only for the bravest. But now, before finishing and actually getting to the most important slide of this PowerPoint, I would like to simply give you a small overview of an application and its WrapToR hierarchical frame. So let's do it with a little example. Let's take, for instance, a macro connectivity of N-link and K-junction. We then use a MATLAB code to convert it into a micro connectivity, where several custom lattice junction will actually connect all the trusses. Of course, now it's time for manufacturing, and of course, as you can see, our WrapToR setups can now produce all the trusses we like. Junctions, instead, is a little bit more complex, but following steps number 4 and number 5, we can simply render the junction into a 3D printable geometry that can now be handled. Now, this is the most important slide for me. And it's a big thank you to Bristol Composite Institute and UAB, because, well, my generation of PhD has been cursed by the pandemic, but actually in my life, even something worse has happened. And I've always had an idea of dropping out and etc. But thanks to the immense support I've received from my supervisors, from the management team, from also other supervisors, also other professors in the BCI, as well as also technicians in the lab, technicians in the technical workshop. They've always helped me, and actually, if I manage to get to this point, it's a lot on them. So thank you very much, and thank you not for having, let's say, my work something I had to do, but something I really wanted to do. I really enjoyed, so thank you very much.
Thank you, Giuseppe.